Welcome, welcome. Yeah, small introduction. My name is, as said, Patrick van der Bleek. I'm a solutions engineer for Docker, which basically means I get to speak a lot about containers. I travel throughout the Benelux region and the Nordic countries in my role, talking to all kinds of customers about how do we deploy containers into production, because that is the biggest challenge we see so far. Little background for me, I've spent about 17 years working with Linux now on a professional basis. I come from a company that is famous for open source, which I have a former colleague of mine sitting in the room. So now, just joined Docker a couple of months ago. We just started European operations, so exciting times ahead. We're scaling our organization quite rapidly as we speak. So thanks for having me. Who was in the presentation we did last year here? Nobody? Well, we could do a rerun. Sorry? Do it again. No, then I'm going to have to throw away the rest of the presentation. Now, last year we were here, we did a presentation on what we call Docker Data Center, which is now called Enterprise Edition. We did a small name change. Basically, what you see here is the container engine layer you see there, that is what people know Docker from. Docker as the platform of deploying containers, especially in the development world, on a single host. That is what the Docker project delivered the past few years and what people know Docker from. With the Enterprise Edition, we're aiming at a much larger scale, looking into the entire life cycle of an application and trying to deploy containers as a service in a large IT operations environment. What we provide on top of the normal Docker engine here is all kinds of features like security, but also manageability of containers. We try to provide enterprise plugins so you can actually start deploying containers and plug into your enterprise network infrastructure and create networks for containers on the fly. We've got certified containers, which I'll handle a bit later in the presentation as well. And of course, a complete user interface managing all of the infrastructure that is needed to run containers at high scale. This is the typical modern software supply chain. Shouldn't be a new picture for anybody. Where have we seen Docker for the past couple of years? Basically, in the front line of the application lifecycle. Developers use Docker extensively. Why? It gives them the ability to run an application inside a container on their laptop, just as it would be on a production-like environment. They don't have to care about the underlying infrastructure. They don't have to care about network connectivity. They don't have to care about underlying patches, hardware, virtualization, whatsoever. That has been what's going on for the past a few years, especially in development. The biggest issue we see as Docker right now is, okay, how are we going to bridge that gap between the developers and the IT operations? Anybody in the room running containers at scale in production at this point in time? That's not really. Yeah. We're going to have a cup of coffee later on. Now, that's the biggest challenge we see. Containers has always been really focused on the developer. But if you want to take container applications towards production, towards the IT infrastructure, you're going to face a specific department in your organization, which is called IT operations. IT operations has a completely different mindset about running applications. What is these guys focused on? Stability, scalability. How am I going to run this application at large scale? One of the other things they're focusing on is manageability. How can I make sure I can manage this as efficiently as possible? How can I make sure that the infrastructure I'm running on is highly standardized? And one of the other ones that is really important to IT operations is security. And that's the one that I want to discuss today. Basically, security in containers boils down to three main topics. You've got secure platform. Basically, how do I make sure that the underlying infrastructure is secured in a way that if a container has a security issue, it doesn't affect the underlying infrastructure or other applications running on top of that. Secure content. How can I make sure that the applications and images I'm running are trustworthy and don't contain any strange security vulnerabilities? And the other one is secure access. How do I make sure that only the right people have access to the container infrastructure, and making sure that nobody can run containers if they're not allowed to, and vice versa. Making sure that team A has no access to the resources that development team B should be able to use. And as I mentioned before, we're trying to bridge the gap between development and IT operations. So our focus is mainly on delivering the developers the user experience they have been used to work when using Docker on their laptops, on their development environments, but still giving IT operations the control and standardization that they so desperately need. So, secure platform. What does a secure platform mean to most people? Does anybody remember roughly 10 to 15 years ago when virtualization was first introduced? The problem that people had, how is this going to be secure? Why am I sharing my physical system with multiple applications? Is this safe? Can I make sure that one application that has a security vulnerability is not impacting the other application running on top of my host? That discussion is basically repeating itself again. Most of the time when I talk to a customer, I get the question, how safe is this? How can I make sure that that application is really isolated from the rest of my applications? Then I remind them about the discussion we had about virtualization 10 to 15 years ago. And then I show them this one. I'm not saying that Gartner is the overall company that has it right on a technological perspective. They're no security experts, but they do make a point in here. Basically, what we see happening right now, the level of isolation that is at the container space is on par with what virtualization has to offer. The other reasoning behind this, in this block you can read from Gartner, is that the attack surface on a container is a lot smaller than it would be on a virtual machine. Why is that? You package only what you need inside of the container instead of creating a complete virtual machine with an entire operating system with all packages you might need for any specific tooling in there. So the attack surface is a lot smaller, making overall containers a lot safer than it would be on a traditional virtualization infrastructure. How do we do that? Basically, what we provide out of the box is all of the container safety measures that are provided by underlying operating systems. Out of the box, we use all the namespaces. Anybody familiar with namespaces? Namespaces is basically a feature in the Linux kernel which provide you with isolation of system resources. I'll name a few. The PID namespace is basically providing an application inside a container with its own version of the process table. It doesn't have any awareness of other processes running on the operating system because it cannot see them. Net namespaces, for example, is completely separating the network stack for a specific given container. So each container that is deployed basically gets its own virtualized IP stack. They get their own IP address, they get their own host name. They don't know about the underlying physical or virtual network infrastructure that is attached to the host. User namespace where you can actually start mixing around user IDs. So we can have a root user in a container which has a completely different user ID than the actual root user on the underlying operating system. Another one interesting, C groups, that is, has to do with security, but mostly on resource management. C groups is what we do to create an application in a container, place it in a profile which basically manages the amount of system resources an application inside a container could actually use. So we can limit the amount of resources a container uses. Let's say you can have a maximum percentage of CPU time. You can have a maximum limit of memory usage that a container can use, but it can also guarantee the amount of resources that a container can use. Then we come to the last three, which is basically depending on the flavor of Linux you're using. Per default, we use seccomp on basically every Linux distribution. Seccomp is a profile in which we put a container in where we can limit the ways that the application in the container can interact with the operating system and using system calls towards the underlying kernel. We use that on basically all the specific Linux flavors, blocking every system call except the ones that an application or a container actually needs to be able to run. The other ones, AppArmor, SE-Linux, depending on your flavor of Linux using. Most of the Red Hat derived distributions use SE-Linux. AppArmor is being used in the SUSE world. What you'll see happening there is you can actually turn it on, run those containers, and those security mechanisms provide you with an additional layer of isolation on top of what's already provided by namespaces and C groups. Making sure that your host, which runs the Docker engine, is secure is also of concern. If you run a Docker engine, you can actually expose it to the network, so you can have a client talk to the daemon on the server. You want to make sure that that is a secure connection. You want to make sure that the Docker socket, which is basically the entry point for the Docker API, is secured so that nobody can access it except the people that should be able to access it. To help you with that, we created a tool called DarkerBench, which is basically a container image you can pull from the Docker hub and run it on your local Docker engine. And what it does, it will look at the configuration of your Docker engine running on that specific system and provide you with best practices on securing that specific platform. You can just pull it, run it, really easy to use, and it gets updated frequently with every new version of the Docker engine with all kinds of best practices around security. When you start using containers at scale, you're starting to think about cluster management and orchestration. Then you get into a completely new world of security. Secure cluster management is what we call at the core of our orchestration tool, which is called Docker Swarm. What we do there, for example, we do least privilege orchestration. We have nodes in our cluster which are managers and which are workers. Manager nodes are the ones that you typically don't run any containers on. Those are just a couple of nodes, normal situations, 3, 5, or 7, always an odd number, depending on the number of failures you want to be able to tolerate. And you run your applications on the so-called worker nodes, which is normally a lot more systems depending on the number of applications you're actually running. The worker nodes have no idea about the rest of the cluster. These are fully isolated. They have no capabilities of deploying applications. They have no capabilities of orchestrating applications across the cluster. They don't know anything about the managers in the cluster. They're fully separated. They can only see themselves as one single host. They know that they're part of a swarm, cannot reach the other nodes from that perspective. We use cryptographic node identity based on what we call mutual TLS. So all communication between the swarm is secured based on mutual TLS. So each system in the swarm has a certificate which not only encrypts the traffic between the nodes, but also authenticates the node to the actual cluster. That will help you make sure that no worker node can ever simulate a manager node, for example, because based on its identity, it is known in the cluster as a worker node, and it can never obtain that specific level of management. Seamless PKI infrastructure, automatic cert rotation. Basically, those certificates are created whenever you deploy a orchestration cluster, and those get rotated every once in a while. So each of the nodes in the cluster get new certificates on a regular interval. The minimum amount of time you can set that to is 30 minutes. So each cluster node will receive a new set, refreshed set of certificates every 30 minutes. And of course, you can use an external CA. Normally, we'll use self-signed certificates to do so. But if you want to have signed certificates from a trusted CA source, we can integrate with that as well. So that's in regards to the underlying infrastructure. Secure content is something that is of most concern right now to almost all of the companies we talk to, and especially in the IT operations department. When we look at what the questions are we see right there is, okay, where did this image come from? What is inside the image? Can I trust this image? Can I deploy this in my production environment knowing that it at least has the latest patches? It's up to date on security vulnerabilities, etc. Who here has ever run an image that he pulled from Docker Hub? Should see more. Who ever done something with Docker? Those are the people that probably have pulled an image from Docker Hub. If you do Docker pull, you're getting an image from the Docker Hub. Docker Hub is a public registry, which means you'll find images there provided by vendors, large vendors which maintain their images. But you'll also find images there from the guy around the corner who did a hobby project at home over the weekend. And he had built a Docker image, pushed it to the hub, and it's still there a year later. Is that image being updated? No, probably not. Is the image that comes from a software vendor being updated constantly? You would expect so, but it depends on the vendor, of course. First, one of the capabilities we provide in our platform is what we call security scanning. Basically, we were able to scan all images that are available inside the Docker Trusted Registry, which is basically a similar setup of Docker Hub, but on-premise or in your private cloud environment attached to the Docker platform. What security scanning does, it looks into each container image that is in there, identifies all of the layers and components in that image, and actually scans it to the most up-to-date version of the CVE database. After the scan, it will show you all of the components in the web user interface, and it will tell you exactly which component in the image is vulnerable to which CVE, with, of course, a link to the CVE item on the website. Other thing it does is provide you with information on the license that comes with a specific part of the image. So, for example, if you're using open source technology inside that image, it will tell you also which open source license is attached to that specific image, which might be of real interest to companies because of compliancy reasons, of course. And also, if you're building software, you want to know which type of license is attached, because some open source licenses are less restrictive. Some open source licenses are really restrictive when it comes to derived works, etc. The other one we provide is what we call Docker Content Trust. So security scanning is more about the content of the image, making sure that all patches and so on in the image are up to date, helping you provide a more secure environment that is not vulnerable for the latest security issues. Docker Content Trust is more around how can we make sure that we can trust the origins of an image. How can we make sure that when an image traverses throughout our infrastructure, from development to test to acceptance to production, that it's not altered, that it's still the same image that was pulled out by the developers to use and build their applications on top of. We use that by signing images. So we can actually have users in the platform, which are authenticated through the platform, sign their images. I'll just grab a couple of use cases to give you an idea of how that works. For example, image forgery. If we provide a developer with an image, and that image has been provided by IT operations, they've scanned it, they've hardened it, they make sure they update it every once in a while on a basis that is required by the security compliance, and somewhere in between, that image gets tampered with. The signature on that specific image does not only tell the image that it comes from a trusted source, but it also tells you if the image has been changed in between the travel between one environment towards the other one. So if that actually image has been changed, immediately the signature on that file will turn invalid, and you'll know immediately if that image is still trusted. Replay attacks. Anybody familiar with that? Basically, let's say I have an image which was trusted. Then a security vulnerability for the specific image came out, and I updated the image. I pushed it to my registry, made it available for my developers, and at some part in the life cycle, somebody with bad meanings makes me fool in using an older version of the image, which still has the security vulnerability inside of it, so that they can make use of it and then do their further hack attempts. By using content trust image signing, we can actually invalidate older image signatures on a file. So when we push a new file into the image registry, we sign it, then we can automatically invalidate the former signature on the former image, making sure that those kind of attacks are no longer possible. And of course, because we provide keys to all of the people in our organization which should be able to sign images, those keys can get lost, those keys can get compromised. Within Docker Content Trust, we have a security hierarchy using a root key, which is basically the one you have offline in the vault, don't use it publicly, which can invalidate keys as well. So if a key gets compromised, you can actually invalidate the keys or the images that were used. The images, you can invalidate the images that have been signed with that compromised key. And then you can start re-signing them again with a valid key. How do we see this happen with our customers in production? Basically, what we see a lot of them do right now is signing images across stages towards production. As I said in an earlier example, let's say IT operations wants to keep control of what the base image is that our developers get to work with. They create a base image, they harden it, they put tools in it that they might need for security or compliance reasons, and when they're done, and they say, okay, this is an image that we as IT operations can stand behind, we can support, and we can maintain, we sign it. Developers are only allowed to use images signed off by IT operations. So basically, when we start pushing that application towards our development environment, they're building on top of that signed image. Next step is when the developer has added this application towards the image, he can sign off on that as well. putting an additional signature on top of that image, making sure that when the image goes to development or acceptation, it has both signatures on top of it. Last step could be, okay, now we're going to push this image to our production area. Let's mark it as sign off for production. At that point in time, there's 3 signatures on that specific image. With Docker Content Trust, we're able to actually enforce the environment to run only images which have a set of specific signatures on top of that. So in the example we just gave, we could be able to say to our cluster, in this environment, which is our production environment, we will only allow images being deployed which have a signature of IT operations, a signature of the development team, and a production sign-off signature. Otherwise, we will not run those containers for you. Third part is secure access. How do I make sure that nobody that is not allowed access to my environment doesn't get that access? We use role-based access control within our environment. Basically, we've defined a couple of roles for you, and in future versions, we're going to add more fine-grained control to that, making you able to create your own roles with your own sets of abilities for those specific users. The 5 roles you see right here, no access, view only, restricted control, full control, admin control, basically are the ones built into the product. And we can loop those into not only specific users, but also teams, and teams can be part of organizations. Throughout the entire environment, based on the user interface for the management platform, but also the trusted registry, and also the Docker client, which you can have on your command line, uses one set of specific authentication and authorization certificates for each specific user. So what we can do, for example, is have a developer run his own Docker client on his local laptop, which he's been used to, give him his, what we call client bundle, which is basically a set of certificates created by the system. He can load them into the local Docker client on his MacBook or whatever he's running on, and that will actually connect to the CAS platform, making sure that he can do his Docker run commands, Docker up, Docker stop, Docker start, all of the commands he's been used to working with, but have them executed on the remote platform under the role-based access control restrictions that apply to his user ID. RBAC controls are tied into what we call labels, and basically we can apply labels to most of the resources in a container environment. So we can apply labels to networks, we can apply labels to containers. In the next version that comes out, we can even apply labels to specific nodes, making sure that a specific set of users can only interact with specific resources in the cluster with a label based on the role that we've provided to that specific user. So that way you can make sure actually that the guys in development have no access to your production environment, for example. They have no ability to run a development container and attach it to the production network, as an example. One of the last ones in the user access space is what we call secrets management. Who knows what a secret is? I see one finger. Who knows what a password is? Nobody knows what a password is? A password is what you type in when you log into a system. Basically, if an application uses a password to connect to another application, let's say a web application connecting to a database, they'll use a set of credentials, but we call those secrets. For some reason, for humans it's a password, for an application it's called a secret. I've seen secrets being stored in places you don't want to see them being stored in. I've seen them being stored on file systems, plain text in text files. I've seen them being stored inside images. I've seen them being stored in plain text files in a Git repository where the source code is living. Heck, I've even seen companies putting them in a wiki. Yeah. What we provide with secrets management is basically we have a secrets store inside the cluster where you can actually safely put all your secrets which your applications need to be able to access resources or services running in another container. When it is at rest in that specific store, it is always encrypted. It is covered by RBAC control, so only the specific user that has created the secret is allowed to view it and to manage it. And it is only exposed to a container when the container is being started, has access to it according to the permissions in the cluster. And after the container is being stopped, the secret is being stored inside the cluster again and encrypted at rest. We make sure that only containers that are allowed to use that secret can actually read the secret, and we block other components in the cluster from reading that specific secret. We don't expose it to a file system. We always keep that in memory. So if the container crashes, the secret is gone. Because normally if your container crashes, we'll leave the file system that the container is writing to on the system so you can troubleshoot it. In this case, it is in memory, container crashes, the secret is gone, and it's still at rest, encrypted in the database. So, going back, 3 main challenges on the security areas. Secure platform, making sure all applications running inside containers are fully isolated from each other. One application being vulnerability and being hacked has no impact on other containers because the isolation that is in place. Out of the box, we supply default security profiles. If you deploy it on a Red Hat Enterprise Linux system, for example, will enable and run default on as a Linux. Same goes for SUSE, AppArmor by default. DarkerBench to help you secure the host configuration in an easy manner, and secure cluster management. Secure content, 2 important items to remember: Docker Content Trust, image signing and image verification, and security scanning, looking at vulnerabilities inside images stored in your environment. And secure access, role-based access control. We can integrate with your LDAP environment or your Active Directory, and of course the secrets management. If you want to try out, please go to our website. You can download Docker Enterprise Edition, use it for free for at least 30 days. If you want to make sure you want to know more about how to secure containers in a large environment, I really would recommend to read the reference architecture we just published on our website, which goes into detail of all of the topics I just discussed, goes into a bit more detail, explains you how to implement that, making sure that the container platform is end-to-end secured. And as our chief security officer at Docker would say, you'll have safer apps. That was basically what I had to tell. Any questions?
So, any questions or comments from the audience?
Hello, I'm the security guy in the room. I have a question about image signing. So could you describe a bit in more detail how it works? I mean, I've seen other products not in this area, but in other spaces that do image signing, and they have inherent problems. You know, you can modify configuration files, you can repackage applications. They still look the same from a signing perspective. It really depends a lot how it's built.
Yeah. What we do is, it's a project we call Notary. Notary is a open source framework based on the update framework. When we deploy Docker Data Center, you get the Docker Trusted Registry, and next to the Docker Trusted Registry, we deploy a Notary server, which integrates with the user management of the platform. And as I said earlier, every user can have its own client bundle, And in the client bundle, there's a set of certificates which provide the trusted chain. The user will enable his local Docker client when he's doing the build to enforce signing. And when he does that, he'll sign that specific image using his own private key. When it gets pushed to the Docker Trusted Registry, there's roles in the notary server telling the Docker Trusted Registry which users are allowed to sign which images and with which roles. So there's a direct link to the integrated user management interface. Then it gets stored into the Docker Trusted Registry together with the signature. And when you look at the deployment, we just enforce the image signing and saying, okay, this image needs to be signed by this specific user. And because that part of the system is also capable of having those public keys for that user to verify that it is actually being signed by that specific user.
So in essence, you probably generate some sort of checksum of the actual image.
Yeah.
Because the problem is that the fact that you sign it doesn't mean that nobody can change a particular element or a module.
The signature is created from the private key, and it acts as a checksum on the content of the image.
Any further questions? Well, actually, I could have one question. Yeah. So you covered in a way quite many of the security features of Docker EE. So let's turn it around. So what security features Docker EE does not provide, and what kind of security concerns you actually have to take into account when you're an application developer?
I think the most security concerns are there. The talks I have with customers are mostly about the security scanning. And questions I get a lot is, okay, are you going to be able to scan, for example, for the inclusion of malware into the image? That is something that is of interest to us, but on the other hand, that makes the complexity of the application a lot more, makes it more complex. And on the other hand, you can scan for malware, but you can scan for malware that is known to providers. And what we see happening a lot, of course, is companies creating their own applications. It's mainly used in the development cycles. You're not able to scan that specific custom-built software because it's not known for malware, etc., etc. So there's a lot of discussion going on right there, but that is one of the things we're looking into if we can add that to the product as well.
Okay, so do you have any questions?
I have a question. You mentioned this in Docker Hub. You have like this some sort of. It was started with a B, I think. Some sort of image that you can like pull, and it gives you some security practices or.
DarkerBench.
DarkerBench.
Yeah.
Okay. If you want to do your own registry, do you get that DarkerBench in a Docker Trusted Registry, or do you have to pull it always from the hub?
You pull it from the Docker Hub.
Because if Docker Hub is like compromised, all the tools you get from that image are compromised in a way. So isn't that like one vector?
That could be a backdoor if you decide to use it in that way. On the other hand, you can pull it from the registry using your laptop and then push it to your trusted registry where you can do scanning, you can check the image for yourself if you would like. And then you could sign the image actually saying, okay, I've done all the checks, this is a trusted image, and then you can deploy it in your environment and run your host configuration checks.
Okay.
Otherwise, it is an open source project. You can go to the GitHub repository for DarkerBench, and you can get all the code and build the image yourself if you trust that more. But it's a matter of trust, of course. And trust is something you have or you don't have, and you have limited ways of enforcing trust. And we're trying to help you get those limited ways of enforcing trust into the platform.
Yeah, thank you. About Docker Content Trust in your own trusted registry, is it like, how does it like work? Is it like a switch you turn on like one checkbox, how you put like enforce Docker Content Trust, or how does it actually work?
You don't enforce it in Docker Trusted Registry. Docker Trusted Registry is just capable of storing signatures. So the enforcing of content trust is what you do on the platform itself. So yes, you go to the user interface, you toggle content trust on, and from that point in time, you can make it as complex as you want. You can actually start creating users and organizations, and you can say, okay, I want images to be signed by this user or by this team or whatever, and otherwise it just won't run. So you can make it rather complex, but all of that is done in the user interface.
Thank you.
Okay, thanks.